Hey guys, we are running electromagnetism lecture 11. Today's subject is you guys can understand like this is transformers, primary, winding part, you know what I mean? Or widely we say like magnetization characteristics curve and saturation characteristics of steel core. Okay, you guys just can understand it like as a transformer. Okay, let's move on. So you guys we already know in the transformer we use steel core, right? Like a magnetic material. We say magnetic substance, right? So you guys need to know about this electron spin, magnetic dipole, and magnetic domains. I'll explain, okay? Okay, look at that, guys. Here's both atom. I will just simply make it. This is nucleus, okay? And there's protons, and here's electrons, right? But first of all, you guys, current and magnetic force. I said it's you know what I mean. Current also could be cause and could make the magnetic field, and magnetic force also could be the cause and could make a current. I'll explain why it happened. Okay, so as you know, the electrons it also it do a revolution around the atoms. You know what I mean? On the orbit, it's revolution. And itself, electron itself, it also spins. We say rotation, right? So we say the electron itself spins. We say electron spin. You know what I mean? So you guys remember the current happened when the electrons moves, right? Electrons now rotate itself, right? So look at that. It's a rule thing here. Electrons, if the electron rotate like this way, and the current rotation is total reverse. Okay, it's a rule. I could explain, but we are electrician. We could, we need to understand like widely about this part. Okay, so look at that. You guys can see the Ampere's law, right? The current is my thumb here, right? As you can see, the current spins here, right? Like this way. So my thumb is here, and the rest of my fingers is from here coming out, right? The magnet, and it gotta be returned back to this part, right? Coming out from here. So each electrons gotta be small. Look at that. Coming out part is N, and getting part is S. It gotta be small magnet. Okay, we say this is a magnetic dipole. Okay, let's move on. So I explained here. Look at that. Since we use magnetic material, for example, steel core, so it has a there's a many in the atoms there's many electrons, right? And it moves like I said, electron spins, and it gotta be electron itself, it gotta be magnetic dipole. You know what I mean? Like this. And in the core still, there's thousands of many of the magnetic dipoles there is. Okay, and as you can see at first time, this is randomly, right? The direction is the arrow's point is N, and here we start S. Okay, DHF start is S, arrow part is N. So the direction is randomly. But here's the thing: at first time, if there's no external power or energy effect, if it didn't impact, even though it is randomly arranged, but every single of their magnetic dipoles adds value, it's 0. Okay, that's great thing. Let's look at more. So look at that. So if we energized, magnetized, it gotta be you could see here the direction is changed from randomly, right? So we say this is a magnetized. So for example, I said steel. Now we have a steel core, right? And there's the core is winding, right? Same, because as I said, current also makes magnet, right? Magnet also cause the current. So it's the same. We don't need to to do this. We don't need to make it magnet this side and this side and we don't need to do that. Look at that, for example. Okay. Okay. This picture, as you guys can see, this is a magnetic dipole. But just to try to understand easily, I'll make it just only 2. 1, 2. Okay. Here's N, S, N, S, right? This is the same. If the there's a steel core and we wind the cores here, right? So if the current follows here, so which means external outside of energies it effect, you know what I mean? So look at that. First time here, this is N part is attracted to here, right? It's at first time this is 0, right? And the outside of when we let's see, when we input the current here on the coil, so it's slightly, it depends on the magnitude. Okay, the current is magnitude. So we did a little bit current input here, so it's magnetic dipoles move a little bit. Also this side also move a little bit, right? As we already learned about the vectors, right? So it moves now. So the two of them's add value is not 0 right now, right? And for example, look at that. So tab, okay, I will say, look at that. The first stop here, and second here, and third is here. Also same. It depends on the outside of magnitude, magnitude. So we say this, as you can see, it moves little bit, it moves, right? If we input the current, for example, right? Then at this time, it's maximum value now. Look at that. Maximum value. It cannot go like this way, and this can, okay, for example, this, I will say this 1, 2. This one cannot go here, okay? This is the maximum value now, okay? 90 degrees, okay? So what I want to say is, guys, look at that. So as a result, we say when they get the maximum value, you know what I mean? We say this is called saturation, okay? Coils, I know. The steel cores, the steel cores, it gotta be saturated, we say, okay? Let's move. I'll make a graph here, look at that. Here's H, and here's B. This is internal, you know, flux density, magnetic flux density, internal, okay? And the unit is Tesla. And here's outside of the magnetic magnitude, we see the units ampere meter, okay? We could just say this is current, okay? Same. So look at that. At first time, when it, okay. At first time, these two values, add values, 0, right? And when you know, put in the here in the core, okay, this is a core, and this is a coil. And when you input the current here, gotta be a little bit moved, like look at that. If I, you know, input the more current, the magnet density, you know what I mean? Magnetic flux density is gonna be also increase. But sometime when it reaches it, I will say this, when it reaches, sorry about my mouse. Okay. When it reaches here, we say the maximum value. When it get this maximum value, we say saturation. Okay, so which means steel core, or as I said, where is it? Look at that. As I said, magnetic material like steel core or magnetic substance, it cannot avoid the saturation situation. You know what I mean? It's a property, characteristics. Okay. But okay, so you guys try to understand this part, okay? And let's look at more. So I will say, okay, give a sec, guys. Okay. Kind of messy today, right? I'm trying to, you know, explain by my best. Sorry about guys, kind of messy. Okay, first of all, you know, which system, you guys know which system we use, like voltage source system or current source system? Which one we use generally? Of course, yeah, voltage source system we use, which means, look at that, guys. So we use the voltage source system, right? So which means we wanna, these voltages, we wanna constant, and the R we say load, right? It gotta be motor or something, you know what I mean? And depending on the load, the current is changes, and we use the voltage is constantly, you know, try to keep the constant value. So we say this is a voltage source system. Look at that. At first time, here was H, and here was B, right? This was a magnetic flux density, right? So density means, look at that. This is the steel core, right? But which means, this inside of this space, which means the flux is how much it is, coming through, which means, right? So we say this is just a pi, because flux we say, right? Not density. And this is also, I said, outside of the magnet magnitude, right? But as I said, magnet equal also current, right? Just as you guys can remember, like a mirror. I mean, look at that. This is a mirror. And I'm standing here, right? And also I could see on the mirror, in the mirror, I could see this. So this is me current. And inside of a mirror, I could say magnet. So it's not equal, but we're gonna say it's a kind of equal, right? Because it causes it make, and it also causes, of course, it also causes, and it could make it this. So that's why I also, yeah, that's why I wanna change it. So this graph, this is I current, and this is just flux. So what happened? Oh, sorry guys. First of all, here's permeability. When it the BH, graph, these slopes, it indicates permeability. Okay, but when it changes to I and pi cover graph, this the graph is the same. Okay, we just changed the units. Okay, the graph's properties, the calculus is the same. But in this case, this slope, you can see. Okay, guys, change it. Okay, okay. You guys can see this slope is now we can say inductance. You know what I mean? Inductance. I pi is inductance. Later we will learn about circuits made it in the circuit we will learn about RLC. Okay, R is resistor, L is inductor, C is capacitor. We already learned a little bit about capacitor, right? Dielectric, right? If you guys didn't know, I mean, if you guys didn't know what I'm saying now, you guys should watch it, okay? I mean, we will learn more deeply, but try to understand, my lectures concept, accumulate, 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 and gotta be smart engineer, okay, guys? So L, right? So look at that. Here's omega L, right? Omega L makes a reactance. We will learn about later. So which means X is equal to R. Not same, but just try to understand that this time is coil's resistance. Okay, I'll explain when we start our lecture, like circuit lecture. I explain more. Okay, so we say this omega also 2 pi f, and omega is angular velocity, angular speed, I will say, angular velocity. So now if you guys listen this kind of specific term, it gotta be complicated. Today's main point is to understand the saturation part. Okay, so look at that. This is the result in a voltage source system. Since we use a voltage system, right? So when the iron core is saturated, this part, right? And the inductance sharply decreases, so that current increases rapidly. We don't know what is that right now, okay? But I will explain. Look at that. So there is a slope you can see here. Okay, this is 1 slope here, and this is 2 slope. This is 3, and this is 4, and saturation part is 5, right? So inductance is, decrease, right? Look at that. At first section like this, and second this, third this, 4 this, 5 this total, right? Look at that. As I said, this is reactance is, I said, R, right? The course R. So look at that. Since we use voltage source system, so look at that. R equal X. So we say this is V is a constant value, right? Same value try to do. But if R is 0, it gotta be I gotta be infinite. You know what I mean? Actually, it cannot be infinite because of a real resistor. But what I mean is it sharply, increase. But there isn't actual fault thing happened. But because of the steel core's, characteristic, I mean, saturation, exactly. Suddenly, the current increase rapidly. You know what I mean? That's it. So try to understand this concept, really important, guys. So you can see this picture. Okay. So look at this picture. As I said when we started the lecture, I say this, you can guys think like this part is transformer's primary part. Look at that. This is core, and this is core. This is core winding, right? This is a steel core, right? That's it. Transformers. So transformer also, we need, if we don't understand the saturation and this curve and why suddenly, the current is increase, we will know. So when we started after circuit, then I will try to make the transformer part. So we will learn more about transformer easily, you know what I mean? We don't need to, struggle just to memorize. That's it, today's lecture. See you guys.